Hello viewers, this is a small introduction to pull up and pull down network. Along with I am covering just two more little topics like why not single NMOS and PMOS we are not using, and after that I will give an example of static CMOS logic design. So first of all, what is pull up and pull down network? So let me tell you first why we use this. Consider this is a digital network with two input. There is two switch A and B, and this is my source VCC, say 5 volt, and this is my ground, and there is output. So these pull up and pull down networks used to bias my floating points. That means when there is this switch is not connecting to any other inputs, neither logic 0 nor logic 1, that is ground and VCC respectively. So there may be cases where this switch may take logic 0 or logic 1 or in between any values, and according to output happens. So there is one thing we can do. Okay, let me delete these things. So we can do one thing. Okay, there may be a solution like this. You may think that my two switch A and B are directly connected to VCC. Okay, that finds that is my output. Okay, that finds. But when what will happen when these two switches are directly connected to VCC? We say logic 1. Okay, but as soon as my switches are close, when I just switch this close in order to input logic 0, there is a direct path from VCC to ground. That is my problem. And what problem it is? Because a huge amount current is flowing from this source to ground, network may damage. So this is not a solution. Okay, so what we can do? I can do another thing. If my network is something like this, then what will happen? So now when I close my switch, there is not a direct path from source to VCC, because now there is a resistance that will resist my current. So this is a pull up net. Now what? Now strictly if we go through this definition, so pull up network is providing a high resistance path from when output logic is 0, and a low resistance path when output logic is 1. And what is pull down network? Pull down network is when my output it is connected between. And what is pull down network? Pull down network that provides a low resistance path to ground when my output is 0, and high resistance path to VCC when my logic output is 1. Okay, now why not single? In coming to why not single NMOS or single PMOS? Now let me take this circuit. So what will happen is there, and this is a NMOS, single NMOS, and this is my VCC, this is source. source, this is gate. Sorry, this is gate, this is drain, and this is source. Typical NMOS. Now suppose there is an input signal like this, and at the source terminal I put a capacitor. Okay, so when when NMOS is on, we know that a minimum voltage to on NMOS is equals VTH, threshold voltage. VTH threshold voltage. So when when this circuit is switched on, capacitor is charging through VCC to ground, charging. Okay, plus minus polarity, you know. Now the question is, what amount is up to its charge? Say when capacitor voltage is close to VDD or VCC minus VTH, and my source voltage is also say VDD. Now if I take a difference between VG and VGS, then this is VTH. Now what it is indicating? It is indicating this, as this value VDD minus VTH is getting higher, this VTH gets decreasing. VTH gets decreasing. That is, my capacitor or output load can never charge up to VDD. So main conclusion is that a single NMOS circuit cannot pass a logic 1 strongly. Okay, cannot pass logic 1 strongly. Same thing can be shown by a PMOS, that a single PMOS cannot strongly pass a logic 0. Okay, delete all these things. Okay, now coming to here comes CMOS. Now another reason of using CMOS instead of NMOS, single NMOS or PMOS, is that this is input. So when this is input and this is output, so when logic 0 is there or low voltage, we know that PMOS is on, and for high logic 1, NMOS is on. So at a time only one device is on and other will be off. So there will be only a small fraction of time when both circuit will be on. And what will be that time? Yes, NMOS circuit, say PMOS is going from on to off condition, and NMOS is from off to on condition. That transition time, we can see the output, there is small spikes. Okay, but in case of NMOS or PMOS, in single NMOS or PMOS, when this is on, there is a direct path from VCC to ground continuously. That is, when steady state is there is a constant current dissipation and power dissipation is happening. So this may be also reason that we use CMOS instead of this. And the last thing, here I am telling only about static CMOS design. Now what is static CMOS design? Static CMOS, as you see, as you know that there is no power, no clock After that there is many things like pass transistor, transmission gate, and the dynamic CMOS design. I will tell another time. So this is static CMOS. Sorry for that handwriting. Okay, so say I have to design a logic like A B plus C D whole pi. Okay. First consider this. So I think you understand that why there is a duplicate or replica of NMOS network and as well as PMOS network in a CMOS network. Okay. So this is a AB. First of all, look at this expression AB, A and B. Okay, so so this must be in series. Okay, AB, also C and D. So this C and D. Okay, and there is a plus. So this AB and CD are in parallel. Okay, this is parallel. Now first draw this. Now upper side. Now what will happen in PMOS area? NMOS is using. Now what is PMOS? PMOS is nothing. Just break these two things. There is parallel connection. So here must be series connection. Okay. Now look at this. AB are in series. So here AB are in parallel. Here also CD are in series. Here CD are in parallel. Now in NMOS, AB and CD are in parallel. So here AB and CD are in series. And this is my source. This is it. And there, sorry, got to put the ground. Okay. And one more important thing is that this is for middle. Here is my output. Okay, output is this. Now if there is a normal output required like okay, do one thing, if there is no bar here, then what will, then nothing, we just have to place a CMOS inverter, normal CMOS inverter. You know what it look like. This is a normal CMOS inverter, and we have to play it. We have to place it in here. Okay. If you require a normal output, just for inverter output, this is enough. Okay. Thank you.